All right, today we're going to dive into a really core piece of crypto security, hierarchical deterministic wallets, or, what everyone just calls HD wallets. We're going to be looking at extended keys. This is the tech that totally changed the game for managing crypto, both safely and at a huge scale.
So what's the big puzzle we're trying to solve here? Well, imagine you're running an online store. You need a brand new, unique crypto address for every single customer. We're talking maybe thousands a day. But putting your master private key, the one key that controls all the money on a live web server, that is a recipe for absolute disaster. So that's the paradox, right? How can a server just spit out endless addresses without holding the one key that could get you completely wiped out?
And believe me, this isn't just some theoretical what if. This was a massive real-world headache for anyone trying to do business with crypto. It was this constant, frustrating challenge they called the many keys problem. The old way of dealing with this was honestly a total pain. You'd have to pre-generate a giant list of keys on a secure offline computer, and then you'd have to upload that list to your server. It meant you were always checking on it, always topping it up, and always worried you were just going to run out of addresses. But the new way, thanks to HD wallets, is just so much smarter. The server makes new addresses on the fly whenever it needs one, and it never ever has to see the private keys. That's not just an improvement, it's a complete game changer. So, what's the magic trick? It all comes down to this really clever idea called the extended key. And the name kind of gives it away, right? It's extensible. Its whole job is to be able to create a whole family tree of new keys, all from one single starting point. So, an extended key isn't just a regular key. It's actually two things bundled together, a normal key plus this special piece of data called a chain code. Think of it like a key plus a secret recipe. If a normal crypto key is just a single leaf on a tree, an extended key is the entire branch. It has all the information it needs to grow every other leaf connected to it.
And this is where it gets really brilliant, this separation of powers. You have two types of extended keys. First, there's the extended private key, or xprv. This is the big boss, the master key for its whole branch. It can create everything: child private keys, child public keys, the whole shebang. This is the thing you lock in a safe and never let it see the light of day. But then you have the extended public key, the xpub. It can only create child public keys. It has absolutely zero power to spend any money, and this is the part you can safely put on your web server. And here's what one of these things actually looks like in the wild. You can see it starts with that xprv prefix, so you know exactly what you're looking at. And yeah, it's long. It's way longer than a typical address because it's packing all that extra info, the key and the chain code, all into one. And this is its public twin, the xpub. Now this is super important. You can create the xpub from the xprv, but it's a one-way street. You can never go backwards. So if a hacker gets a hold of this xpub, sure, they can see all the public addresses, but they can't spend a single cent. This is how you get all the convenience without sacrificing security. Okay, theory's great, but let's see this in action. This ability to create public keys from another public key, well, that's the shortcut that powers so much of what we do in crypto today, from online stores to our hardware wallets. Let's go back to that online store. As the owner, you take your xpub, just the public one, remember, and you install it on your server. That's it, setup is done. Now, a customer gets to the checkout. Your server uses that xpub to instantly create a new public key and boom, a fresh, unique address just for that customer. And the whole time your master private key, your xprv, is sitting safely offline, totally untouched. So how many addresses can you make? A handful? Thousands? Nope, we are talking about 4 billion, with a B. For any real-world use case, that's basically infinite. Your server is never, ever going to run out of addresses to give out. This all sounds just about perfect, doesn't it? A secure, infinitely scalable system. But, with engineering, there's almost always a but. There's a subtle little catch we have to talk about. And that catch is called the gap limit. It's a practical problem that pops up because of how wallets have to find your transactions on the blockchain. Think about it. When you restore a wallet from your seed phrase, it has no idea which of your 4 billion possible addresses have any money in them. It can't check all of them, that would take forever. So it takes a shortcut. It checks them in order, 1, 2, 3. And if it finds a bunch in a row that are empty, usually about 20, it just assumes it's reached the end and stops looking. And you can probably see the problem here. What if you gave out addresses 1 through 21, nobody paid you, but then address 22 times did get a payment? A normal wallet would stop searching at address 20 and might never see the money sitting in address 22. So this puts developers in a really tough position. If you hit that gap limit, what do? You're kind of stuck with three bad options. You can stop giving out new addresses and maybe lose customers. You can generate addresses past the gap, but risk that money being invisible during a wallet recovery. Or you can start reusing old addresses, which is just awful for privacy. There's no good answer, just a bunch of trade-offs. Now, even with that gap limit challenge, I really want to stress it is impossible to overstate how big of a deal this technology was. It was a massive leap forward that made crypto both more secure and easier to use in the real world.
So let's just recap the big wins here. First, security gets a huge boost because your master private keys never have to go online. Second, it's just so much more convenient for businesses. Third, privacy gets better because using a new address for every payment is suddenly easy. And finally, this is the magic that makes hardware wallets work. It's how your Ledger or Trezor can give you a receiving address while it's completely disconnected from the internet.
When you step back and look at it, the xpub and xprv system it's an elegant solution. It brilliantly balanced security with convenience, solved that whole many keys problem, and it really built the foundation for so much of the crypto world we have today. But it does make you wonder, right? What's the next gap limit? What's the next hidden challenge that the wallet developers of tomorrow are going to have to solve? Something to think about. Thanks for tuning into this explainer.